Okay, in this lesson, we're going to go through a bunch of very basic problems solving equations that involve logarithms and exponential functions. So let's get to it. So let's take a look at a very basic function like this, and we want to solve for x. What we need to do is we need to take the natural log of both sides, because when we solve equations, we do a series of steps where we undo everything by doing the inverse. So the inverse of an exponent is natural log. So if we take the natural log of both sides, the natural log and the exponent cancel each other out, leaving x on the left side and natural log of 72 on the right side. And if you have to calculate that to a decimal of 3 significant figures, it looks something like this. All right, let's add another layer here. When we want to isolate x, we follow the same steps as normal, where we sort of erase numbers one at a time to get to the x by itself. And so we'll divide both sides by 3. And now that we have to the x, we have to remember we use our log rules to rewrite this expression. We can rewrite this as the log, the exponent of 2 that gives us 14 is x. Right? So we're using our log rule, and what we can do is we can type this into our calculator and get a number. All right, again, 3 significant figures. Now you could have solved this differently. We could have maybe taken the natural log of both sides, for example, and then we can use our log rules. We can now take that x and move it out to the front, and now we can divide both sides by a natural log of 2. Okay, and so we could type this into our calculator and arrive at the same answer. So you're going to see different ways, different pathways to the same answer, and the more familiar you get, and the more you ask yourself, how many, is there another way that I can do this, and practice those, consciously practice those, the more your confidence is going to be built, and you'll really sort of demystify logarithms, and you start realizing that they are very doable. Anyway, here's another function. We want to divide both sides by 4, get this expression. What should we do from here? I would take the natural log of both sides. That way the natural log and the e cancel out. So I just get something like this. All I have left to do now is divide both sides by 2, or I could have written this as 1/2 natural log of 5/4. It doesn't really matter, because this is just going to go straight into a calculator and give me an answer to 3 significant figures. Okay, now we're adding some more layers, but it's all the same. Let's get rid of this -4 first. We're going to divide both sides by 2. We end up with an expression like this. What should we do? Well, we can take the log base 3 of both sides. I am going to go ahead and take the natural log of both sides, because what I'm going to do is I'm going to move this out into the front. So I'm going to have that move out into the front. That's going to, and then I'm going to divide both sides by natural log of 3. Now I'm going to get something like this. Don't type this into your calculator yet, because you're going to have some rounding issues. What you're going to do is you're going to add 5 and divide by 2 first. Type all of that into a calculator, and you're going to get something like this. And 3 significant figures would be 3.42. All right, though you wouldn't be docked for something like this. That's more. All right, so here, anytime that you have, you see this little 2 out in the front, and you've got a trinomial and it equals 0, that should be a clue that you're going to be doing some factoring. All right, and so what we're going to do is we're going to really think of this as e to the x to the second power, and then 3 times e to the x and plus 2. So what we're going to do is we're going to sort of think of, instead of x squared minus 3x plus 2, now we're going to have e to the x squared minus 3 to e to the x. And so all that's going to do is, instead of writing x here, we're going to write e to the x instead, right? So e to the x squared. This, you can think of this as e to the x squared. So this is going to be e to the x times e to the x. What we do is we add the exponents, right? And so x plus x is 2x, right? And let's multiply this out. Minus 2 e to the x minus 1 e to the x gives you negative 3 to the x, and then negative 1 times negative 2 gives you 2. All right, so you might have to pause and take a look at that a little bit more closely. You know, change e to the x to x and see if that makes any more sense to you. But moving forward, it's the same. We have a product that equals 0, so either this equals 0 or this equals 0, so you set them up. And then we realize that e to the x equals 1. We could take the natural log of both sides and get that x is equal to 0. And over here, move 2 over to the right, take the natural log of both sides, and then get an answer. Okay, so over here we're going to have some natural logs. We're going to start off with functions with natural logs and go the other direction. So if I have the natural log of x is equal to 2, I can raise both of these, make both of these the exponents of e. Okay, by doing that, I've done the inverse, and these two cancel out. So what's going to happen is I'm going to get x on the left side. And I'm going to e to the 2. We type that into calculator, so this should be 7.39. Over here, we've got a little bit of a mess. But something that helps us is that I should notice that I have log base 3 here. So hopefully you'll see that those we can just simplify that to this. These two expressions equal to each other, and after that it becomes very easy. But initially it looks very intimidating. Okay, let's solve for x here. We'll go ahead and subtract 5 from both sides, and then divide both sides by 2. We get something like this. How do we solve this? Well, you make both of these the exponents of e, and then that just makes this just an x. So on the left side we'll just simplify it to x. On the right side we get something like this. Again, you can take that into your calculator and get something like this. Okay, let's do another one. How would we isolate x in this particular case? I would divide both sides by 2. All right, what should we do from here? Well, you need to rewrite this using your log rules, right? The exponent of 5, so 2 is the exponent of 5, that gives us 3x. All right, so we rewrite it like this. This becomes much easier. Now all I have to do is divide both sides by 3 and get my answer. Okay, what if we have something much more complicated like this? We need to isolate x. We've got x in various places here. It looks very much like a mess. Pause for a second. Think about how you might approach this problem. Okay, hopefully you've decided that you can start condensing. I mean, there's a bunch of ways to approach this. What I've chosen to do is start using some of the log rules. All right, I've decided that I've got the sum of 2 logs here. I can make that the product here. And then if I have 1 log and 1 log over here, what I can do is I can just set these two expressions equal to each other, right? By taking e, making this the exponent of e on both sides, and so they cancel out. So so then I have something like this, and I've eliminated the natural log, and now it's just straight algebra, and I can get something like this. The reason why we have an x cannot equal 1 here, well, why is that? Well, what if I substituted 1 into my original equation? What would happen? Well, we would get some negative signs here, right? What's the natural log of -1? Well, if we remember the domain and range of natural log, um, we can't have we can't input a negative value into the natural log. Our domain is x greater than 0. So if we have a negative number, then we get undefined. So we can't put a negative number into a natural log. So if we substituted 1 in for these expressions here, it would give us negative numbers. And so this is actually not one of the possible values of our original function. So only x equals 6. Now let's try a word problem application. So going back to our basic continuous compounding interest problems, we have an initial deposit of $500 and it pays this much interest. It's continuously compounded, so that means we use this formula. We seek this formula. This is the continuously compounding interest formula. How long will it take your money to double? Okay, well, A is the amount of money that we have after the compounding. So we started off with 500, so we want to know how long it takes us to get to 1,000, right? Double. All right, we substitute, we have to change our percent interest into a decimal. And now what we have to do is we have to solve for t. We have to figure out how much time it takes. So let's divide both sides by 500. What do we do from here? Let's take the natural log of both sides. All right, natural log of both sides here gets rid of the exponent. Now if I divide both sides by this decimal, I will have my t isolated. I can type that in, and this should be the units we're assuming is going to be years. So I should have put years there. So about 10.27 years to double my money at this interest rate. So that's an application of how to use these rules. Hopefully this was enlightening.